So we're going to play around with the idea of greatest common factor. We'll start with some pretty simple examples, and then we'll move on to something a little bit harder. So let's consider 12 and 16. And I want to know factors of these numbers. I want to know about common factors of these, and then I want to find the greatest. So one way to go about this is to just list all factors. And I showed one technique earlier for listing factors, and that's the idea of making factor pairs of a number. So for 12, I have 1 times 12, and then I have 2 times 6, and then we just keep going in order. 1, 2, if 3 works, use it. 3 times 4, and after 3, I would pick 4, but I already have that in my list, so I'm done. For 16, we're going to always have 1 times 16. 2 works because it's even. 2 times 8. 3 doesn't work, but 4 works. 4 times 4. So my list is complete there. So as far as common factors go, we have a common factor of 1, and a common factor of 2, and a common factor of 4. So we have lots of factors. We have some in common factors, but only one of them is the greatest of the common factors. Right? 4 is the greatest of the common factors. So if we have a list of all the factors, we can easily identify what's the biggest one that they have in common. Now, if the lists are bigger, right, that's harder, but it's doable. So method number 1 is to just list all factors. So in a moment, we're going to try a bigger pair of numbers like, say, 84 and 90. But I just want to show another way to go about doing this. And that would be using prime factorizations. So another option, so option 2. Versus this right here was option 1, list all factors. So for 12, for any number, the usual way I do it is I make a factor tree, and there's many ways to do it. I choose to use primes, and 2 is the first prime number. So 2 goes into 12 6 times. And then once I have a prime, I'm done with that branch, and I move on to the other branch. 6 is even, so I'm going to use 2 again. 2 goes in there 3 times. 2 and 3 are even, so I'm done. So the prime factorization, 12 is 2 times 2 times 3. And often prime factorizations, we write them in order from least prime to the greatest, and we use exponents. So I would say that's 2 squared times 3. And then for 16, 2 goes into 16 8 times, 2 goes into 8 4 times, and 2 goes into 4 twice. And so I can see I have 2, 4, 6, 8. Sorry, why did I do that? 2 times 2 is 4, times 2 is 8, times 2 is 16. There's 4 2's, so that would be 2 to the 4th power. 16 equals 2 to the 4th power. And when I'm using the prime factorizations, it's got to be a common factor. So the only common factor is 2 for prime factors. Now this one has 2 2's, this one has 4. At most in common, right? I'm looking for what they at most have in common here, would be 2 of those 2's, so 2 squared is the most they have in common there. And it turns out, right, I'm picking the lowest power I see of the common primes, and we'll see that more carefully again, and I'll state that more carefully. So let's try that again. So I'm going to do option 2 first, and then I'll do the list of all factors in a moment. So for 84, 2 goes into 84, 42 times. and 2 goes into 42 21 times. 21 is not even, so I move on to 3. 3 happens to go into 21 7 times. 3 and 7 are prime, so I have the prime factorization. So 84 has a prime factorization of 2 squared times 3 times 7. And then we do the same thing for 90. 2 goes into 90. 45 times. 2 doesn't go into 45, but 4 plus 5 is 9. So 3 goes into 45. How many times? 1, 5, 15 times. And then 3 goes into 15, 5 times. And again, there's many ways to make a factorization tree like this. Somebody might have, at this stage right here, done 5 times 9. But either way, you'll get the same list of factors. And if I list them in order using powers, 90 has a single prime factorization, 2 times 3 squared times 5. Now, we're looking for the greatest common factor based on these primes here. So first, I just think about common factors. Okay, well, they have 2 in common, and they have 3 in common. Do they have more than 1 2 in common? And the answer is no. This one has 2 2s in its factorization. This one only has 1. So at most, there's 1 2 in common there. For the 3, this one only has 1. So at most, they have 1 3 in common. They don't have a 5 in common. They don't have a 7 in common. So at most, for common factors, they have a 2 and a 3. So I claim that 6 is going to be the greatest common factor of these two numbers. And the strategy here, again, because we're looking for factors that are common and the greatest of them, is if one has more of a particular prime than another, right, that there's too many 3s in this one compared to that one. So at most, I can take the lowest power of the common primes. And so that's the strategy. You want to grab the lowest power of the common primes. And if you get those and multiply them, that's the greatest common factor. So let's look at the full factor list for each of those to confirm that 6 is indeed the largest number that divides both 84 and 90. So that's when we look at the factor pairs to get a full list. So 84 versus 90. And here we're going to do the list method. And to do the list method, we do factor pairs. So 1 times 84 is my first pair. 2 times 42 is my next. Does 3 go in? Well, 8 and 4 is 12. 3 goes into 12, so 3 must go into 84. Grab a calculator if you're not sure how many times. Let's see, 3 goes into 8 twice. 24 left over, that would be 28 times. 2 went into 42, 84, and the result is still even, so 4 must go in. And that would be 4 times 21. 5 clearly doesn't. Since 2 and 3 both went in, 6 is going to have to go in. So that's going to be 6 times 14. And I'm just using arithmetic tricks to get those. If you're not sure, whip out a calculator. How many times does 6 go into 84? Let's see. 7, I remember 7 goes into 84. 12 times. 8 does not, because 4 goes in and the result is not even. 9, 8 plus 4 is 12. 9 doesn't go into 12. 10, nope. 11, nope, because 11 goes into 88. 84 is too close. And then the next number to check is 12, which I already have. So I'm done checking 84. If there's a long way between these two last factors, it's not a bad idea to whip out your calculator and take the square root, because that will also tell you when to stop looking. So let's just double check that since I have a calculator hanging out, board over here. The square root of 84 is 9.16. So we can stop looking at around 9 is what that tells us, which is right in between the 7 and the 12. All right, 90. First pair is 1 times 90. 2 goes into 90 45. 3 goes into 90 30 times. Let's see, 4 doesn't because 2 went in and the result's odd. 5 goes in because it ends in a 0. So 5, how many times is that? Thinking it's 18, but I'm going to double check with the calculator. "90 divided by 5 is 18. Two and 3 both went in, so 6 goes in. 6 goes into 90 15 times. 7, no, 7 goes into 84, which is too close to 90. 8 doesn't go in because 4 didn't. 9, obviously 9 times 10. And 9 and 10 are as close as you get. So I'm done looking right there. So there are all the factors. And then remember, we're looking for the greatest common factor. Greatest common factor. And so usually I like to list all common factors. So they have a 1 in common, and a 2 in common, and a 3 in common. A 6 is in common. No 7, no 12, 14, 21, 28, 42, 84. So none of the other factors here are in common over here. So I'm done looking, and I can see that the greatest of those in common is 6. Which is what the prime factorization told us before also. All right, so those are the main 2 methods for trying to find common factors. And this is kind of like our area model for playing with factors. And then the prime factorization is just a whole nother area of mathematics. It's not really related to the area model or the linear model. It's just this more abstract way to calculate that.